Today's lesson is on conditional statements. This will be day 1. I'm going to teach this lesson with a foldable. So I'm going to go to the end where I have my vocabulary first. We're going to talk about our learning objectives, what a conditional statement is, a hypothesis, a conclusion, a truth value, and a counterexample. And if you print this foldable out, the vocabulary is mirrored from the inside. So these words belong with the inside on the left side of the vocabulary, and these words belong with the inside on the right side of the vocabulary. All right, so let's get started. So our learning objectives are: I can identify the hypothesis and the conclusion of a conditional statement by labeling them P and Q. I can write a conditional statement by writing it in if-then form. I can determine the truth value of a conditional statement by stating if it is true or false and providing a counterexample for any false statement. I'd like you to take a minute right now and decide, where are you on understanding this? So if you've never heard of this before, you'd be a novice. And if you've had this before in some place, you'd be an apprentice, practitioner, or expert. So just take a moment and think about where you are. All right, so let's start with what is a conditional statement. So a conditional statement is a logical statement that has a hypothesis and we call that P, and a conclusion, and we reference that as the letter Q in math. So the form of the statement is if P then Q. In symbols, I do P with an arrow to the right, Q, and I say it as P implies Q. So the hypothesis is the if part of a conditional statement written in if-then form, but it does not include the word if. And this is what happens first. The conclusion is the then part of a conditional statement written in then if-then form, and again, it does not include the word then. And this is what happens second. So let's do an example. So we're looking up here in the top box. If I get paid, then I will take you to the movie. So anything after the word if, I'm going to underline once and label that as P, the hypothesis. Then I will take you to the movie. Anything after the word then is the conclusion, and I'm going to underline that twice and label it Q. Let's try the next one. If an animal is a blue jay, then it is a bird. So again, after the word if is the hypothesis, and I label that P and underline it once. Then it is a bird. Anything after the word then is the conclusion, and I label that Q and underline it twice. How about if you take a turn and you pause the video while you label the hypothesis and the conclusion. Okay, so if a bird is an insect, anything after the word if is the hypothesis. Then it has 6 legs. Anything after the word then is the conclusion. Okay, let's come down here to this box now. If there is rain outside, then the sidewalks are wet. So anything after the word if is the hypothesis, P. Anything after the word then is the conclusion, Q. If this month is August, then next month is September. Anything after the word if is the hypothesis, P. Anything after the word then is the conclusion, Q. Okay, the next one is a number is an integer if it is a natural number. So this time, the word if is not at the beginning of the sentence. So I want to rewrite it so that it is at the beginning of the sentence. Okay, so here's my word if. So I'm going to rewrite. So if it is a natural number, then a number is an integer. Now that we have it in if-then format, now we can identify anything after the word if is the hypothesis, P. Anything after the word then is the conclusion, Q. Sometimes we can have our conditional statements in a Venn diagram. So whatever is on the inside is the if part, the hypothesis, and whatever is on the outside is the then part, which is the conclusion. If I have a word that is defined as, or a statement that says all birds have red feathers, the all is the if part. And the then red feathers is the then part. So I would rewrite this as if bird then red feathers. So the bird is the hypothesis and the red feathers is the conclusion. So here's another example. So let's rewrite this in if-then form. So whatever is on the inside is the hypothesis P. Whatever's on the outside is the conclusion Q. I would write this as if plain, then undefined term. Okay, so now I want to decide if my statements are true or false. So if the if part is true and the then part is true, then the whole statement is true. If the if part is true and the then part is false, then the whole statement is false. If the if part is false and the then part is true, then the whole statement is true. And if both parts are false, the whole statement is true. This is the beginning of programming and logic and programming. So the case that I'm very interested in is this one right here, where the hypothesis is true and the conclusion is false. So in math, true means it has to happen 100% of the time, and false means everything but 100% of the time. So I need a counterexample when I say that my statement is false. for this situation. So I have to have a statement. So let's decide if these statements are true or false and provide a counterexample. But let's first define what a counterexample is. So a counterexample means counter means against. So this is something that to show that while the if part is true and the then part is false. Okay, so here's a couple examples. So if you live in Irving, then you live in Texas. So the hypothesis is you live in Irving. The conclusion is you live in Texas. So the hypothesis is true. The conclusion is true. So the whole statement is true. Okay, so the whole statement is true. So when both parts are true, the whole statement is true. Let's try the next one. If there is rain outside, then the sidewalks are wet. So if there is rain outside is the hypothesis, then the sidewalks are wet is the conclusion. So I'd start by saying you're assuming that the first part is true. And then I'm saying the sidewalks don't have to be wet. And right now it actually just rained outside by my house. And in backyard under my porch, the sidewalk there is not wet. So whenever I'm saying this is false, or my statement is false because the hypothesis is true and the conclusion is false, whenever I say the statement is true, I have to have a counterexample, and I could say under the porch. So my sidewalk would not be wet under the porch, or my sidewalk would not be wet under the car, or my sidewalk would not be wet under the umbrella. I got all kinds of examples I could say that even though it rained outside, the sidewalk is not wet. Okay, so the midpoint of a segment bisects the segment. So if I'm labeling my hypothesis and conclusion, the midpoint of a segment bisects the segment. So the point M, the midpoint M of the segment bisects the segment. So the bisects the segment is the beginning part. So that's the hypothesis. And the midpoint is the conclusion. So if my segment bisects the segment, so that part is true, and the conclusion is true, then my whole statement is true. So I have no counterexample. I don't need a counterexample for the first one. So I just need a counterexample when I have a false statement. So last example, if a number is odd, so here's my hypothesis, then it is divisible by 3. Here's my conclusion. So odd numbers are 1, 3, 5, 7. Then it's divisible by 3. So I would say the hypothesis would be true. And my conclusion I'd say is false. So I'd say my whole statement is false. So I need a counterexample, and I could use the example 5. So 5 is not divisible by 3. Okay, that's the end of today's lesson.